Okay, folks, welcome. My name's Ted. Um, as you would know, I decided today's topic because I just wanted to keep exposing people to things that I think are great. This particular article, well, I should say that I have titled this, with as much hyperbole as I possibly could. I think that this is the most important article on software development ever written, which is a pretty big thing to say. So if I'm going to say that, I should probably back that up. Now, what do I mean by most important for software development, right? If we're thinking about, say, something that started the field, right? Like, I'm not talking about an article by Alan Turing or some of the pioneers of the field, because that I think is not really something that the average everyday software developer would necessarily be able to do something with. What I'm talking about is an article that when I read it, for me personally, had a really big impact. What I would say is that in my own life as a programmer, it marked a watershed moment, okay? So there was kind of my life as a programmer before I was introduced to Casey Muratori and Handmade Hero and this article that I'm about to read to you. And then there was my life afterwards, okay? So this article is important to me because it marks this pivotal transition, what I would say, in my life from what I would call like a mid-wit kind of a programmer to somebody capable of doing his own games from scratch, doing his own game engines, having the kind of confidence to approach really any programming problem. I think it's that important. Okay. I also believe that it's consequential because it is something that I use every single day. It's not the kind of thing that I could that I might reference this occasionally. I might sometimes use what's described in this article. No, this is actually something that, practically speaking, I use every day. The skills in this article, I would also say, are something that could be very useful in any job context, although there are a little bit of caveats because culturally, the content in this article goes against the dominant culture in software and very much clashes with the object-oriented mentality. And so if you find yourself working in the way that is described in this article, which I believe is very productive and very pleasant, as Casey describes, then you will find that in your own working life, you're going to butt heads with the folks who want to keep pushing object-oriented ideology and whose perhaps career depends on it, perhaps their the perception of them as the ivory tower intellectuals. If you show them that there's a different way, they don't want to accept that, and so that's been a bit of a problem for me, in spite of the fact that I think it's so consequential. So I believe it's the most important article on software development because it deals with the plumbing of software development, because it deals with the pragmatic everyday realities that we face as software developers. Okay. So the article is titled Semantic Compression, and it is, of course, written by Casey Muratori. It was written right around the time that Handmade Hero started. So this is actually my birthday, May 28th, on in 2014. I was not born in 2014, obviously, but it was written on my birthday. This would have been around the time that Casey started Handmade Hero. And so it kind of dovetails with that project. So without any further ado, without much more background, I'll just start reading it and reacting to it and maybe adding a little bit of my own experience. So here we go. Semantic Compression by Casey Muratori. We all know how to program in C++, don't we? I mean, we've all read a selection of wonderful books by the gaggle of bearded fellows who defined the language in the first place. So we've all learned the best ways to write C++ code that solves real-world problems. First, you look at the real-world problem, say a payroll system, and you see that it has some plural nouns in it. Employees, managers, etc. So the first thing you need to do is make classes for each of these nouns. There should be an employee class and a manager class at least. But really, both of those are just people. So we probably need a base class called person, so that things in our program that don't care whether you're an employee or a manager can just treat you as a person. This is very humanizing, and it makes the other classes feel less like cogs in a corporate machine. There's a bit of a problem, though. Isn't a manager also an employee? So manager should probably inherit from employee, and then employee can inherit from person. Now we're really getting somewhere. We haven't actually thought about how to write any code, sure, but we're modeling the objects that are involved, and once we have those solid, the code is just going to write itself. Wait, shoot, you know what? I just realized. What if we have contractors? We definitely need a contractor class because they are not employees. The contractor class could inherit from the person class because all contractors are people, aren't they? That would be totally sweet. But then, what does the manager class inherit from? If it inherits from the employee class, then we can't have managers who work on contract. If it inherits from the contractor class, then we can't have full-time managers. This is turning out to be a really hard programming problem, like the simplex algorithm or something. Okay, we could have manager inherit from both classes and then just not use one of them. But that's not type safe enough. This isn't some sloppy JavaScript program, but you know what? Bam, I've got the solution right here. We templatize the manager class. We templatize the manager class and its base class, and then everything that works with manager classes is templatized on that as well. This is going to be the best payroll system ever. As soon as I get all these classes and templates spec'd out, I'm going to fire up my editor and get to work on UML diagrams. Okay, so I think we've all been in that situation, or we've worked with people who are like that. That it is the quality of working with object-oriented programming feels like that, especially if you sit down and you try to plan the whole thing out in advance. It always feels like you're shoehorning something into some system that wasn't really designed to be there, and you end up with this big tangled mess before you've even started. So, okay. Programmers posting programming posts. It'd be great if everything I just wrote had been farcical, but sadly there's actually a lot of programmers in the world who think like this. I'm not talking about Bob the intern. I'm talking about all kinds of programmers, including famous programmers who give lectures and write books. I'm also sad to say that there was a time in my life when I thought this way too. I was introduced to object-oriented programming when I was 18, and it took me until I was about 24 to realize it was all a load of horse shit. And the realization was thanks in no small part to my taking a job with Rad Game Tools, which thankfully never bought into the whole OOP nightmare. Okay, yeah, my experience is, I sort of feel like Casey had it much better than me, although in different ways. I didn't really get into professional programming until I was in my late 20s. So I wasn't actually making money programming because I basically spent my 20s snowboarding, and then when I was 28, I made my first iPhone apps, and I did that using Apple's UI kit, and those actually started to make a little bit of money. So I got my start kind of as an entrepreneur, and I was able to then take my skills with iPhone apps and hawk them to various people who would purchase those skills and start to pay me money. And so when I first got into making iPhone apps, I was very much indoctrinated into the object-oriented mindset, precisely because so many of the kits and tools that you are presented with as a mobile app developer are object-oriented, or at least they were at the time. Now it's shifted a little bit over to this more complicated, almost late Baroque thing called Swift UI, but that's a different discussion. Nevertheless, I felt a need to buy into object-oriented programming. I felt a need to learn about it, to use it, because it actually was my day-to-day life making iPhone apps. And so I probably spent all the way up until I was maybe 35. Yeah, it's about that 6 years. 34 and 35 is roughly when I was introduced to Handmade Hero. So it would have been about that long. And I probably spent about the same 6 years that Casey did, which is sad. I mean, Casey got an earlier start, of course, than I did. But, it's interesting to me that we both wasted those 6 years really, really doing this, But despite the fact that many programmers out there have gone through bad phases like this and eventually come to smart conclusions about how to actually write good code efficiently, it seems that the landscape of educational materials out there still overwhelmingly falls into the objectively bad category. I suspect this has something to do with the fact that good programming seems very straightforward, and once you know how to do it, unlike, say, fancy math technique that retains its sexiness and makes you want to spend the time to post about it. So, although I don't have any data to back this up, I strongly suspect that experienced programmers rarely spend time posting about how they program because they just don't think it's anything special. This is an interesting theory I've had for a while, actually. One of my running theories about why we have these complex things in the workplace like object-oriented programming is because it makes a job that is otherwise straightforward and boring seem much sexier than it is. So, for example, if you are working, like let's say you're writing something that just processes spreadsheets, right? I actually wrote software like that. I wrote some tax software to do that. I wrote my own tax software, okay. So let's say you're writing your tax software. It actually is just very straightforward, and it is very boring. Not exactly inventing a new game concept, not exactly designing anything, not really breaking any barriers. We're not, getting inspired by Italo Calvino books and making braid. We're just doing taxes, okay? And there's just these forms that you gotta fill out and you just gotta do stuff, right? To make that work seems a lot more interesting if suddenly the programming around it is more interesting, right? So you can maybe take a job that would be otherwise very boring and spin it into this. Now it's a tech job, right? And now it's like, oh my gosh, we're making these objects, and these objects are actually like organisms, man. And like they've got like a cell barrier, and like stuff can get in and can get out, and like, oh my God, this is like, what an amazing, and there's monads. Oh my God, have you read Gottfried Wilhelm Leibniz's The Monadology? And it's like, actually the universe is comprised of infinite amounts of monads. And it's like, yeah, but actually I thought we were just writing a program to do some taxes. That's kind of like, so maybe it's people lying about the fact that their jobs are boring that makes them do this, right? If you had to accept that your job is actually boring, then you might have to face some realities, right? So anyway, continuing. But they should. It may not be special, but it's necessary. And if good programmers don't start posting about how to do good programming, we'll never get out of this nasty place where everyone has to go through 6 years of writing horrible object-oriented programs before they realize they're wasting their time. So what I'd like to do with this next set of witness articles is spend some serious word count talking about the purely mechanical process of putting code into a computer. And it is my sincere hope that other experienced programmers out there will take some time to do the same. Personally, I'd love to read more about the techniques actual good programmers out there use when they sit down to code. To start things off, I am going to detail a straightforward set of code transformations that I did on the Witness's code editor. In the coming weeks, I'll move from that into some larger examples where I wrote more pieces from scratch, but the entire time I'll be focusing solely on code and how it's structured. Nothing that I'm going to cover has any fancy algorithms or math or anything. It's all just pure plumbing. So John starts things off. Right in the built-in editor for the Witness, there is a piece of UI code called the movement panel. It is a floating window with some buttons on it that are used to perform operations on entities like rotate 90 degrees. Originally, it was quite small and had only a few buttons, but when I started working on the editor, I added a bunch of features that needed to go in the movement panel. This was going to expand its contents considerably, and it meant that I had to learn how to add elements to the UI, which I'd never done before. I examined the existing code, which looked like this. Okay, so we've got a comment, by the way. This is such a good article. Yeah, I agree. This is my favorite. Like I said, I think it's the best article ever. I'm not going to read this article exactly, but what I want to point out, and hopefully what you can, I'm not going to read this code. What I want to point out is this is very straightforward. This is actually a lot like the kind of code that I write now, insofar as it really is just stepping through things procedurally, and there's no abstractions in our way. It's just, we're just telling the computer what to do. Okay. The first thing I noticed here was that John, the original programmer, did a really nice job setting me up for success with what I was about to do. A lot of times you open up some code for something simple like this and you find that it is just a massive tangle of unnecessary structure and indirection. Yes, that is my experience working in software, because people didn't read this article and because the education system sucks and they're doing UML diagrams and all that stuff. So a great deal of my frustration actually comes from those kinds of experiences. Here, instead, we find an extremely straightforward series of things happening that read exactly like how you would instruct a person to draw a UI panel. First, figure out where the title bar should go. Then, draw the title bar. Now, below that, draw the auto snap button. If it's pressed, do auto snapping. This is exactly how programming should go. I suspect that most anyone could read this code and know what it was doing and probably intuit how to add more buttons without having to read anything beyond just this excerpt. Yes. Yes. This is why in my own games, most of the code that's central to the game is actually just in one big file. It's locality of reference is what we like to call it. That's a fancy way of putting it. But another way to put it is, I don't have to jump around all the time. I can just do stuff. Okay. However, nice as the code was, it was obviously not set up for doing large amounts of UI because all the layout work was still being done by hand in line. This is mildly inconvenient in the snippet above, but gets more onerous once you consider more complex layouts, like this piece of the UI that has 4 separate buttons that occur on the same row. Okay, so more code. This is a kind of thing that will happen a lot, especially in user interface code. I'm going to talk some more about my own user interface work that I've been doing for a game that I'm working on. But you will very frequently get into this kind of a situation where it's like it's just a row of buttons and you find that you're doing the same thing over and over again. And so it starts to get handy to do what Casey is calling semantic compression. So before I started adding lots of new buttons, I already felt like I should spend a little time working on the underlying code to make it simpler to add new things. Why did I feel that way? And how did I know what simpler means in this case? Okay, great. So he's setting us up, defining the terms. Because a lot of times I think people don't necessarily understand what simpler really means. Some people, because they've been taught that simpler is more abstract, or that the code somehow, that there's like less code, or there's like less code that you can see, they think that's what it simpler is. But Casey goes on to give a very good definition, in my humble opinion, probably the best definition of what simpler means. And he calls that semantic compression. I look at programming as having essentially two parts: figuring out what the processor actually needs to do to get something done, and then figuring out the most efficient way to express that in the language I'm using. Increasingly, it is the latter that accounts for what programmers actually spend their time on, wrangling all those algorithms and all that math into a coherent whole that doesn't collapse under its weight. Yes. Yes, that is most of what the job is. And in fact, like, most of what I find is that I can get to like the solving the problem part really fast. It's then figuring out how to fit it in with everything else that takes a while. So any experienced programmer who's any good has had to come up with some way, if even just by intuition, of thinking about what it means to program efficiently. By efficiently, this doesn't just mean that the code is optimized. Rather, it means that the development of the code is optimized, that the code is structured in such a way so as to minimize the amount of human effort necessary to type it, get it working, modify it, and debug it enough for it to be shippable. I like to think of efficiency as holistically as possible. If you look at the development process for a piece of code as a whole, you won't overlook any hidden costs. Given a certain level of performance and quality required by the places the code gets used, beginning at its inception and ending with the last time the code is ever used by anyone for any reason, the goal is to minimize the amount of human effort it costs. This includes the time to type it in. It includes the time to debug it. It includes the time to modify it. It includes the time to adapt it for other uses. It includes any work done to other code to get it to work with this code that perhaps wouldn't have been necessary if the code were written differently. All work on the code for its entire usable lifetime is included. When considered this way, my experience has led me to conclude the most efficient way to program is to approach your code as if you were a dictionary compressor. Like literally pretend you were a really great version of pkzip running continuously on your code, looking for ways to make it semantically smaller. And just to be clear, I mean semantically smaller, as in less duplicated or similar code, not physically smaller, as in less text, although the two often go hand in hand. So that's a really subtle difference to note, the semantic compression as in less text. There are ways to make your code have a lot less text in it, but still be doing more, have more duplicated code than necessary. I don't know if I'm actually discussing that right, but it's a different thing. And there's actually cases what I found where sometimes the code is semantically more compressed, but the text is longer, right? And that's usually in cases where maybe I've only got two instances of the thing that I'm trying to compress. That can happen. So it's important to really pay attention to the difference. This is a very bottom-up programming methodology, a pseudo variant of which has recently gained the moniker quote-unquote refactoring, even though that is a ridiculous term for a number of reasons that are not worth belaboring at the moment. I also think that the formal refactoring stuff missed the main point. That's also not worth belaboring. Point being, they're sort of related, and hopefully you will understand the similarities and differences more over the course of this article series. So, what does compression-oriented programming look like, and why is it efficient? Like a good compressor, I don't reuse anything until I have at least 2 instances of it occurring. Many programmers don't understand how important this is and try to write reusable code right off the bat, but that is probably one of the biggest mistakes you can make. My mantra is make your code usable before you try to make it reusable. I have certainly run into this problem in the work world. I always begin by just typing out exactly what I want to happen in each specific case, without any regard to correctness or abstraction or any other buzzword, and I get that working. Then when I find myself doing the same thing a second time somewhere else, That is when I pull out the reusable portion and share it, effectively compressing the code. I like compress better as an analogy because it means something useful, as opposed to the often used abstracting, which doesn't really imply anything useful. Who cares if code is abstract, right? Actually, I would go further on that point and say that code which is more abstract is often more difficult to understand and difficult to read. And so I think very much so pointing out that abstracting is really not what we're doing. Compressing is the better way to describe it. It hits on that other point of I want to be able to read what I'm looking at. This is a problem that I have found with, say, template programming or generics programming. Oftentimes it's so up there in the air that I just want to get down to the specific case we're talking about. It's very hard to understand. And although it may seem quote unquote compressed, the fact that it's often more abstract than it needs to be makes it confusing and difficult to work with, in my experience. Waiting until there are at least 2 examples of a piece of code means I not only save time thinking about how to reuse it until I know I really need to, but it also means I always have at least 2 different real examples of what the code has to do before I try to make it reusable. This is crucial for efficiency because if you only have one example, or worse, no examples, in the case of code written preemptively, then you are very likely to make mistakes in the way you write it and end up with code that isn't conveniently reusable. This leads to even more wasted time once you go to use it because either it will be cumbersome or you will have to redo it to make it work the way you need it to. So I try very hard to never make code prematurely reusable, to evoke Knuth. Similarly, like a magical globally optimizing compressor, which sadly pkzip isn't, when you are presented with new places where a previously reused piece of code could be reused again, you make a decision. If the reusable code is already suitable, you just use it. But if it's not, you decide whether or not you should modify how it works, or whether you should introduce a new layer on top or underneath it. Multi-resolution entry points are a big part of making code reusable, but I'll save discussion of that for a later article since it's a topic unto itself. Finally, the underlying assumption in all of this is, if you compress your code to a nice compact form, it's easy to read because there's a minimal amount of it, and the semantics tend to mirror the real language of the problem. Because like a real language, those things that are expressed most often are given their own names and are used consistently. Well-compressed code is also easy to maintain because all the places in the code that are doing identical things all go through the same paths, but code that is unique is not needlessly complicated or separated from its use. Finally, well-compressed code is easy to extend because producing more code that does similar operations is simple, as all the necessary code is there in a nicely recomposable way. Absolutely my experience once I switched over to doing this. These are all the things that most programming methodologies claim to do in the abstract fashion: build UML diagrams, make class hierarchies, make systems of objects, etc., but always fail to achieve, because the hard part of code is getting the details right. Starting from a place where the details don't exist inevitably means you will forget or overlook something that will cause your plans to fail or lead to suboptimal results. I'm just going to stop right there, take a sip, and this article is so consequential because I cannot tell you how many times I have run into this in the work world doing iPhone apps for clients on various teams that I get into. I had one where I was paired with a project manager who, before the project started, came up with a bunch of UML diagrams for how we were going to organize the whole system. It had class names, it had nice sticks and boxes and lines pointing to other boxes with other sticks. And it sounded nice. It sounded really nice. It sounded like it had a lot of work put into it. And on the first week, we were supposed to just estimate how long it's going to take to do all the stuff that's in the sticks and boxes. And we hadn't even started any development yet. We ended up having to throw all of that out because the reality of actually building the thing hit us in the face. And that always happens. It always happens. It's not just that project. It's many, many, many other projects where I've run into that thing, where people think that they can plan the whole thing up front. They can design. We had another guy on another project that designed all of these beautiful classes and all this beautiful class hierarchy, and he had all of this infrastructure built, put into place, so to speak. And then it just turned out that every feature that he touched was broken because he was never identifying with the ground truth of what his program had to do. He wasn't using the program as he was building out the features. So I have learned, after witnessing time and time again this thing failing, that the best way is to view software as building blocks and to build feature by feature, always with the ground truth in hand. And from there, you can start to build out more and more of this structure of what it's going to be. This is exactly what Casey talks about. If I'm talking about a game that I'm working on, first thing I would do is I would just try to get a rectangle on the screen. And I would do that in the simplest way that I can. And then I might try to figure out how to put some textures into that rectangle. And then I might figure out how to get that rectangle to move. And then I might figure out how to do some collision detection around the rectangle. I might figure out how to draw like a box for a user interface window. I might try to figure out how to put some text in the box. I'm just trying to get those features working first. And then later on, let's think about the structure of it. Okay, continuing. Starting with the details and repeatedly compressing to arrive at the eventual architecture avoids all of the pitfalls of trying to conceive the architecture ahead of time. Let me say that again in case you didn't hear it, because it's the most important thing ever said about software development. Starting with the details and repeatedly compressing to arrive at the eventual architecture avoids all the pitfalls of trying to conceive the architecture ahead of time. Stamp that on your butt. I don't care. Remember it. It is the truth. With all that in mind, let's take a look at how all this can be applied to the simple witness UI code. Now this, I'm not really going to go into many details. You are free to go and read the article and go and look at this. It's obviously great as a pragmatic example, but it's not really something I want to talk about on stream because then I'd just be reading code, and I don't think that you're really interested in seeing me read code, so we're just not going to do that. But what I want to do is jump to the end, just jump to the conclusion. This is worth looking at because Casey gives very great examples of pragmatically, again, this is an article about plumbing, right? It's everydayness. This is, you encounter this every day. So he gives you examples of how to do this, starting with some example code. So I'm not going to read all that. In fact, I'm going to take another sip of water. Okay. Now I want to point out something really important. Did all that seem pretty straightforward? I'm guessing that there wasn't anything in there where you were like, oh my God, how did he do that? I'm hoping that every step was really obvious, and everyone could have easily done a similar set of steps if charged with just pulling out the common pieces of code into functions. Amen. So given that, what I want to point out is this. This is the correct way to give birth to objects. We made a real, usable bundle of code and data, the panel layout structure, and its member functions. It does exactly what we want. It fits perfectly. It's really easy to use. It was trivial to design. Contrast this with the absolute absurdity that you see in object-oriented methodologies that tell you to start writing things on index cards, like the class responsibility collaborators methodology, or breaking out Visio to show how things interact using boxes and lines that connect them. You can spend hours with these methodologies and end up more confused about the problem than when you started. But if you just forget all that and write simple code, you can always create your objects after the fact, and you will find that they are exactly what you wanted. This tends to be what I do. I was just doing this actually. Maybe I even have the code somewhere. Not that people will be able to read it, but what did I do? I just came up with a thing for like buttons for a user interface on my game. Actually, why don't I'll just run it. Okay, this, right? For a while, when I was drawing the buttons for this game, Rogue Deck Builder, I had different functions that were just like, okay, draw this kind of bounding box, figure out the hover state, draw the text. And I was doing, for the very first instances of the button in my game Rogue Deck Builder, that's what I was doing. It was all separate lines of code, just very much like what you would have seen in this article, right? And then over time, gradually, as I started doing this over and over again, maybe not even the first time, maybe you don't even notice it the first time that you reuse it, but probably by like the third or fourth time, when you notice that you need to make another button, right? Eventually you will come upon, or like, okay, so, I place a hot tub on my deck, right? I get this, I've got these buttons here, they all kind of behave similarly. Eventually you're going to come upon some kind of structure or some kind of thing, which I ended up doing. And all I did to make this thing, I called it a button. Let's see. And this is just what it happens, struct button. It's basically a string where it's centered in the layout and where it's hovered. And that just happens to be, is that going to be the final version of button in my game or any of my other software that I make? No, it's not, right? But the important thing to note is that this right now is exactly what I need, and it's good enough. And when it comes to pass in the future that I need buttons to do something else, then I'll change that. And that's how you program, kids. If you're not used to programming like this, you may think I'm exaggerating, but you'll just have to trust me. It's true. I spend exactly 0 time thinking about objects or what goes where. The fallacy of object-oriented programming is exactly that code is at all object-oriented. It isn't. Code is procedurally oriented, and the objects are simply constructs that arise that allow procedures to be reused. So, if you just let that happen, instead of trying to force everything to work backwards, programming becomes immensely more pleasant. I love that he ends on the word pleasant, because to me that is so important. Like I said, I could read the rest of this article. I think that's basically it. To me, this article marks a watershed. It's a watershed moment in my life as a programmer, because there was this unpleasant black box thinking, use a kit all the time, can't really code your way out of a paper bag. I could sort of, but it was harder because you can't really understand what's going on in these black boxes, and you're using all this cumbersome plan ahead kind of thinking, and people are telling you that you're a bad person, you're a bad programmer for programming the way that Casey suggests. And why are they telling you that? I've been told this, okay? So when I've been working certain jobs, I very frequently find myself in a situation where I do exactly what is described in this article, where I will simply solve the problem. Okay, here's the job I had recently. I was working for a major corporation that has hotels and they sell credit cards in their app. Okay. They need to show the credit card ads. Okay. So we need to get some data from a server to figure out what kind of stuff to draw in the credit card ad. We're going to put a new feature in. I'm just writing the straightforward code of when you get this property from the JSON, then you put it into this text field or whatever have you. I don't want to necessarily go into the details, but I had a lot of code that was just like this, just very straightforward. It was semantically compressed, but it doesn't follow the ideological rules of object-oriented programming. And then that goes into code review. And of course, the lead programmer on that team is like somebody who really buys into this object-oriented ideology. And so you take my perfectly fine, simple, straightforward procedural code, and now I get a bunch of red marks on it, and there's a bunch of crap that I got to do to make it fit into his ideology, right? And that's I would say, a very demoralizing experience. And I know, without a doubt, that I am not the only person who has gone through that experience. It very much feels like in today's modern work world, well, this would have been a few years ago, but it very much feels like I have to program the thing correctly, so I've got that job. And then in addition to that, once I'm done programming the thing correctly, I've also got to do this like weird genuflecting to whatever ideology happens to be in charge, right? So maybe the person in charge is really all about object-oriented programming, so I gotta make sure it follows all those rules, and I gotta take this thing that was just fine, and you gotta make sure there's all the getters and setters, and this thing should be a property, and this thing even though we can't have a function that's more than 20 lines, so make sure you take that out, and that's a function. It's got to look like what we think good object-oriented programming should be. And it's a similar thing with, I would say, functional programming. There's, I would say, many functional programming zealots and ideologues out there. And there are people who work on teams. They have to work with these people. And so you've got this extra job of genuflecting. I might be so bold as to suggest that we all start doing that. That we just do what Casey suggests here, what he says, which is very pragmatic. Throw out the ideologies. Throw out the people in the ivory towers. Okay? So we don't have to do the genuflecting, right? We could just make software that works and is good and be happy and have a pleasant work experience. Pleasant. That's how the article ends. Because I found that in my own work, when I am able to work this way, when I don't have somebody telling me that it's not object-oriented enough, that the function is, shouldn't be more than 20 lines, I find that I'm happy. I find that I enjoy my work. I find that it's not cumbersome. I find that I can actually get a lot done. And I know that I'm not the only one. So there you have it. The most important article on programming, on software development ever, Semantic Compression by Casey Muratori. I will now rest and take questions. I take it that the lack of questions indicates that Casey made his point. We have one comment. I fortunately never really dealt much with OOP. I feel blessed. Yeah. I don't know how old you are. So I'm 41, but what I'm genuinely hoping is that the new generation of programmers coming in just never had this problem, right? I feel like I will have done my job as a communicator of things, perhaps, if the next generation coming in starts to recognize these things. We start to know and appreciate what simple, straightforward programming looks like, so that people don't have to be tortured in their work environment like this. I'm 29. I found good info online early in my career. Yes. Okay, great. And I think that's in many ways because there's people like Casey saying what they're saying, that more people can find this information and they can avoid that trap. I didn't have that. Casey's fortunate because he had Jeff at Rad and a number of other people at that team to kind of, push him out of that. And that, I think that's such an important thing, is the quality of information that you get can really have an important impact on you. So it's really important to pay attention to who influences you. So you are very fortunate, and I hope for everyone that's entering programming that the culture does change and we can start getting back to something that makes us happy and satisfied with what we're doing. So with that, I will end, and it's been a blast as always.